The heart pumps blood throughout our body through blood vessels. Our blood vessels can either be constricted or relaxed. The control of that constriction and relaxation depends in part on the endothelial cells. But endothelial cells line the inside of our blood vessels, and they talk to the smooth muscle cells that make up the vessels. These are the cells that cause constriction and relaxation. So here is a picture of two blood vessels. The one on the left is constricted. The one on your right is relaxed. What does that influence? It controls your blood pressure and blood flow.
There are a number of compounds basically which can generate, but the most significant compound which generates blood vessel dilatation from the endothelial cells, which can make the vessels grow bigger so the blood can flow, is nitric oxide.
So, if you're going to do a research study, you want to have a system that actually produces nitric oxide in response to some stimulation. Two of those stimuli that have been known for 2 decades now that increase nitric oxide are insulin, the hormone that controls blood sugar, and a chemical that is called A23-187. Now, the group that is doing these studies in New Zealand took and measured nitric oxide production by cells at 3 hours. So you take cells, you pour in a little nothing or insulin and A23-187, and you see what happens after 3 hours. Now,
this is remarkable. This is remarkable what we see, the chart which we see right here. Tom, go ahead.
Tiny amounts of insulin and A23-87 did produce a stimulation of nitric oxide production at 3 hours. When the group in New Zealand took Nitro Extreme, 3 different samples pulled out of our production line and sent to New Zealand, 3 distinctly different samples, each produced extraordinary amounts of nitric oxide at 3 hours. You guys are sitting on a gold mine, a gold mine.